important research trends in mechanical engineering, which is organized by the Mechanical Engineering Department of Birla Institute of Technology, Durg, Chhattisgarh, and in Autonomous Institute, India, in collaboration with Volo University, Kombolcha Institute of Technology, Ethiopia. I, Dr. S. Prabhakar from the Department of Mechanical Engineering, Kombolcha Institute of Technology, Ethiopia. I welcome you all participants for this final day session of this faculty development program. Today we have a great faculty with us, which is one of the in our Ethiopia. Okay, most of the research directors, okay, they have more experience in their field. So I welcome today our chief guest, Dr. Asamin Haile IG, our Director, Research Community Engagement and Technology Transfer Office of Volo University, Kombolcha Institute of Technology, Ethiopia. I welcome you, sir, for this faculty development program. He is going to take today 1 hour session on the topic nanotechnology, which is one of the latest technologies in the mechanical engineering field. All of the many fields. Okay, nowadays they are focusing on the nanotechnology. So I welcome our today's chief guest, Dr. Asamin Haile, who is the director of our Volo University, Kombolcha Institute of Technology. I welcome you once again, sir. So I'm hand over the session to you, sir. So you can proceed with the session, sir.
Thank you very much, Dr. Prabhakar. Thank you. I also appreciate for inviting me to our presentation on this very interesting title. Thank you very much for the participants of this session. So my presentation title is nanotechnology. Just to introduce myself, I am Asaman Ayaleo from Volo University, Kombolcha Technology, Institute of Technology. As Dr. Pravaka said,
Sir,
just
1 minute, sir. Sir, 1 minute. Host, you can record now, sir. Dr. Santosh, sir, you can record. Dr. Santosh, sir, you can.
Yes, sir. Yes, sir. 2 minutes.
Yeah, yeah. Sorry for the inconvenience, sir. Just wait for a few minutes, sir, so that the session will be recorded, sir. Yeah, thank you, Dr. Divesh, sir. Sorry, Dr. Asamin, sir, for the inconveniences caused. So now we can proceed with the session, sir.
thank you very much again. I just introduced myself. I am Asaman Ayaleo from Volo University, Kombolcha Technology Kombolcha Technology, Institute of Technology. I am very happy for getting the chance to present on this very interesting topic, nanotechnology. Actually, as you said, it's really very interesting and hot issue nowadays. So my presentation is on nanotechnology. I will try to make it very general since the application of nanotechnology is too wide for the human application. I will try to make it very general to make it short and precise. Thank you very much. So my presentation, can you manage my PPT, please, sir?
Yeah, sir, you can just hit next so that I will change the slide, sir.
Okay. So next, my presentation have these outlines. The first one is introduction about nanotechnology, and next one, what makes nanotechnology unique, and some applications and current trends of nanotechnology, and finally I will have the summary of my presentation. Next. As an introduction, let me start from the very simple definition of nanotechnology. Involves the engineering of nano-sized particles of various materials. For instance, if we want to take the definition of the Environmental Protection Agency of the United States, they define nanotechnology as the creation and use of structures, devices, and systems that have novel properties and functions because of their small size. So the big deal in nanotechnology is the size of particles or the size of materials. In addition to this definition, the general definition of nanotechnology that it is the purposeful engineering, or we can say it, the purposeful manipulation of matter at a scale less than or equals to 100 nanometer to attractive size, or to manipulate a certain unique property of the matter. So nanotechnology is about the size of the materials. So next, sir. The other one is when we talk about nanotechnology, there are very important terms. The first one is, as I told you, the size of the material or the particle matters. The other one, the shape of the material, the composition and the structure. When we say the material, the difference between the bulk material and when the material, the size becomes very small in nano scale, the materials or particles, they show a unique property. In addition to this one, the shape of the material, it matters, or it creates a difference in nanotechnology. For instance, in nanotechnology, we may have nanowires, or we may have nanocubes or nanopyramids and other shapes. So having the same material but with different shapes, this there may be different properties because of the shape of the material. Furthermore, the composition of material is very important issue in nanotechnology. For example, you may take the composite materials. In nanoscale, they may have a unique property than the other bulk materials. So in nanotechnology, the size, the shape, the composition, and the structure are very important. Due to the size of the material, due to the shape of the material, due to the composition and the structure of the material, the physiochemical property of materials are strongly dependent on these issues. Hence, especially the size is really have a great role in having different new properties in this technology. Especially in one-dimensional nanomaterials have a higher surface area to volume ratio. This term is very important in nanotechnology. The higher the surface area to volume ratio, that helps us to get a better crystalline quality of materials. The higher integration density. For example, if we take certain devices which are constructed with the using of nanomaterials, the low power consumption of the device and the likes are very important properties that we can get from the surface area to volume ratio. Next. Again, on this issue, this important issue in nanotechnology, the surface area to volume ratio, that the dramatic increase in the surface area to volume ratio. For example, if you take this figure, we have a certain cubic structure in a certain container, but you can see from the figure as illustrated in the figure, when the size of the building blocks of the material gets smaller, the surface area of the material can increase even while the volume remains the same. Surface to volume ratio has significant effect on the properties of nanomaterials. So when the size of the materials becomes very smaller, the surface area to volume ratio increases. Due to this property, due to this case, we can have many different properties of the material that can help us to use in different technological applications. Next, sir. For example, if we consider the nanoparticle of spherical shape having a radius of r, as I illustrated in the previous slide, let us take, for example, the surface area of 4 pi r square, as it is understandable for everybody, and the volume of the sphere may be defined as 4 over 3 pi r cube. If we take the ratio, that means surface area to volume ratio, we can get this this number 3 over r as a function of the radius of the shape. When the same volume is divided into smaller pieces, the surface area is increased. For example, from this final expression, we can get that as the radius becomes larger, the surface area to volume ratio becomes very small, and the material or the structure is maybe in nanometer scale, or it may be in microns, or in any other scales more than the nanostructure. But if the value of r becomes small, the surface area to volume ratio becomes higher, and then due to this important property, we can get so many unique properties of the materials, and we can design different technologies based on these principles. Next, sir. For material property of the material will be changed. The electrical property of the material will be changed. The mechanical property of the material will be changed. The magnetic property will be changed. The physiochemical property of the material will be changed. Even we may have different sensors due to which can be designed by these nanoscale materials. For example, from this figure, you can see that we have certain SAM image. For example, the figure in the right side, which is denoted by B, it is a film, or you can consider it as a bulk material. But the above one, the one I represent by letter A, is a certain nanostructure. Some of the nanostructures are actually in microns, but most of the structures, as you can see from the image, they are in nanoscales. But if we try to compare and contrast the application or the functions of these structures, you can see the photoluminescence graph from the right side, the above one. The photoluminescence behavior of the bulk material is none, no photoluminescence behavior. But if we take the photoluminescence behavior, that refers actually one of the optical properties of this material. We try to construct a certain electrode by using these two properties of the material, actually the shape and the size. So the other one, the one I represent by figure 1, it shows a very interesting photoluminescence behavior at around the visible light range. This difference becomes, this difference is due to the structure of the material. So when we change the size of the material, we can have different surprising nature of these materials. So the photoluminescence property changes due to the change in morphology or the size of the materials, or the same material I'm talking. Thank you very much. Can you go to the next slide, please, sir? Here is that when we see the effect of shape, in the previous slide I tried to show the effect of size. In this slide, the effect of, to explain the effect of the shape of the nanoparticles or the nanomaterials. For example, you can say this figure. From the left side, I try to put two different sizes. I mean, two different shapes of the same material in nanoscale. The other one is actually, you can see a very interesting nanopyramids. And the bottom one, I'm referring the SAM image. The bottom one is the shapes are actually like the truncated nanocubes. So the material is the same. It is nano size cuprous oxide. So we try to design and photoelectrodes based on these properties, and they showed really different properties. For example, in the next figure, the middle figure shows you the photoluminescence behavior. The pyramids, the nanopyramids and the truncated nanocubes actually showed us different photoluminescence behaviors. In the case of nanopyramids, you can see actually there are two main photoluminescence peaks. But for the case of truncated nanocubes, it can be seen that only in the visible light range around 700 nanometer scale, we only observed the photoluminescence behavior. This shows us, even if the materials are the same, even if the scale, I mean the sizes are almost the same, the difference in the shape of the nanomaterials that leads us really different property. So based on this photoluminescence, the property of this, the same material with different shape, we can have a design of a certain optoelectronic device which have different properties. For example, the first one, I mean the first figure of the photoluminescence, the middle figure, we can have lasers which have different colors, but the bottom has only one photoluminescence in the visible light range. This approximately the red color. When you see the other one is photocurrent property of these nanostructure materials. The figure in the right side, we have really the photocurrent property of the nanopyramids is a huge difference than the bottom one. So both scales actually are in micrometer per square. So the amount of photocurrent we can get from the nanopyramid is really enhanced than the photocurrent property we found from the truncated nanotubes. This shows us the shape of nanomaterial is really displays a great difference in nanotechnology. Next, sir. So, having said this one about the shape, the size of nanoparticles, actually the composition is another one. What makes nanotechnology unique? So, it is due to the size of it's due to the size and the shape of this material. The first difference, the first uniqueness of this technology is the size. The other one is what you call the quantum confinement effect. The quantum confinement effect is really another unique property of this material. We may take different materials with like one dimension, or we may take zero-dimensional particles like the quantum dots, or we may take the three-dimensional particles. So due to the quantum confinement effect, we can have really a different unique property of these nanomaterials. In addition to the size and the shape of these nanomaterials, the quantum confinement effect is another uniqueness than the bulk materials. The bulk material, if for example, if we take a certain bulk material for silicon, And if we want to study the same material but in nano scale level, we may get really different behaviors than which are very important for the design of different optoelectronic devices, and this is really very promising for the development of technology nowadays. Next, sir. So on this point, the uniqueness of nanotechnology, the quantum size effect, and the electron confinement, it helps or it describes how electronic and optical properties change when the material size is at nanoscale. The material size is described toward this nanoscale. Then the confinement dimension also decrease. Energy spectrum becomes discrete, and we call it the quantum confinement, or the discrete nature of these particles. When the particles become discrete, we can have unique properties. Maybe our material, maybe the zero dimension, as I mentioned earlier. The confinement is found in quantum dots, which are very important in designing of solar cells nowadays and other optoelectronic devices. One dimensional structure, the confinement is found in quantum wires, and then if they are in 2 dimension, the confinement is found in quantum walls. The next, sir. So when you come to the application and recent development of nanotechnology, really it has a very wide application. For instance, if we take, for example, the information technology, nowadays is digitalization era. So many applications there in nanotechnology. For example, the smallness of the communication device, the fasterness of device and the likes is very important in information technology. The other wide application of nanotechnology is in energy. As you may understand, nowadays the demand of energy is really one of the hot issue in the world. So energy is very important. So when we raise the case of energy, the problem is that how can we produce efficient energy devices, efficient energy storage materials. How can we efficiently produce energy from different sources like solars? When we talk about solar energy, we have to talk about the solar cells, the efficient device to utilize solar energy, the fuels, the biomass, and the likes. So to have an efficient energy, or especially green energy in this era, we have to have efficient devices. So these efficient devices may be manufactured or designed from nanomaterials, which have unique properties. So the other one is about so many applications actually in military application, in telecommunication, in agriculture, whatever. In communication, the application of nanotechnology is really very wide. For example, you may take the automotive technology. Nowadays, very smart and unique vehicles are produced because of this nanotechnology. You can take the aerospace technology, the different devices which is very important to collect information, different smart sensors for different application, maybe for military purpose, or any application is very important. So the application of nanotechnology is very wide. You may take, in our case in Ethiopia, we need really smart agriculture in this time and in the future. So the application of nanotechnology in agriculture is very wide. How can we make our agriculture very smart? Maybe our focus may be to prevent disease, plant disease, or any other issue. So the application of nanotechnology is very wide. In my case, in my expertise, I really tried to manufacture some optoelectronic devices using semiconductor nanotechnology, like photoelectrodes, which are very important to absorb the solar spectrum and solar cells, and lasers and the likes are really very important. You can take the silicon technology nowadays. Very big companies in the world. Maybe you can take the Sharp from South Korea, or the TSMC from Taiwan, and other big countries they are using silicon technology for manufacturing of different materials like cell phones, smart computers, LEDs, and the likes. Is really the concern of nanomaterials. Next, sir. So again, when we talk about the energy application of nanotechnology, as I told you before, an important subfield of nanotechnology is related to nanofabrication. Nanofabrication means we can fabricate any nano-based equipment. Maybe we can take you can consider the recent development in robotics. So we can produce, or we can design different materials, or different necessary materials for the application of nanorobotics. And the application is the process of designing and creating devices on the nanoscale. So when we design in that nanoscale, we can have different unexpected properties of the material. So that really increases or enhances the efficiency of the device. So creating devices smaller than 100 nanometer opens many new doors of the development of this technology can transform energy to the it opens really a new door, or a new technology for the development of for the utilization of green energy. Next, sir. For example, if we take this is actually the application. I want to talk about the application of nanotechnology for storage device like memory. If you take this figure, the top one is 2 GB memory, maybe in 1980s. It's the cost may be around 18,000 USD, but after a time, around 1990, the size becomes very small. Actually, people may use nanotechnology for the fabrication of this type of devices. Actually, the the memory size is the same, but the cost becomes smaller. But the big deal here is that in the nanofabrication, or in the manufacturing of these devices, the manufacturing process is very complex, but the application is very smart. So in 1990s, the price becomes low, around 200 USD. But around 2010, or in the recent time, there may be actually a new development even this time. The same memory size becomes very cheap, around $5, maybe less than this cost this time. So this indicated that the application of nanotechnology is really playing a big role in the development of technology. You can see the size of this memory in 1980, but nowadays very small, very portable, and very huge application, and very smart devices are developed this time. You can maybe you can consider your smartphones very easy this time. but the manufacturing process is really very complicated. Once we pass that challenge, we can enjoy the smart technologies this time. Next. So the other application of nanotechnology is industrial application of in the application of nanotechnology in industries. That means the surface and coating is another very important technology this time. So the most prominent application of nanotechnology in the household is that self-cleaning or easy to clean surface on the ceramic or glass surface. So nano ceramic particles have improved the smoothness and heat resistance of common household equipment such as the flat iron, as you can see from this figure. So the coating is another wide application of nanotechnology for different purpose. Next, sir. The other application of or recent development is that engineering nanofiber or maybe the closes the close water and strain repellence. You can consider this figure as the application of this nanotechnology in textiles with nanotechnology finished. They can washed less frequently and at low temperature. That really changes the property of textiles or textile products. So nanotechnology can be used to integrate tiny carbon particles or the particle membrane, and that guarantees full surface protection from electrostatic charges for wear. So this and the likes are applicable. The application of nanotechnology in textile manufacturing. Next, sir. So just this slide is to show you how wide is and how wide the application of nanotechnology. For example, if we consider the application of nanotechnology in defense, maybe the soldiers may have a unique clothes which have different applications for security. For biorobotics or nanorobots will be used in defense or military application. The application of nanotechnology for information for different applications, really, the military protection, the chemical sensing, the biological sensing, the nuclear detection, and the likes are really very important application of nanotechnology in military or in defense and security application. So nano is very important, and it has really wide application. Next, sir. So when it comes to the final, just I want to focus it that my presentation is actually not very specific. Just to talk about the general, the current trends of nanotechnology. When it comes to the summary, nanotechnology is, I believe, is a brand new technology that has just begun recently. Not really is old technology or old science. It has really revolutionary technology, or you may call it science, that will change all what we know before. It's a new era. It's a new thinking. The future that we were watching in maybe science fictions or in movies will be real or truth in the near future. This is because of the new properties we have seen before. That comes due to the small size, the small size effect, the shape, the composition, the quantum confinement effect. So the world will be changed a lot. So nanotechnology will make life very easy. Actually, the technology by itself, I strongly believe that the, the, the application of technology or the application of engineering is to make life very easy. So, for example, nano robots will it's very important. So nanotechnology will give us an abundant energy because it will transform energy or efficiently. This is because the design and production of efficient device. For example, if we take the solar energy, nowadays there are so many interesting progresses in the fabrication of efficient device to utilize the solar to change the solar energy to electric energy, which is green by its nature. So the energy we will use different source of energy efficiently by the application of nanotechnology in the future. Hence, nanotechnology, as I told you before, nanotechnology, it covers a wide application in human life and it will cover a lot more in the future. So this is actually all about my presentation about nanotechnology. Uh, Thank you very much for your time, and really appreciate for being patient for my presentation.
Thank you, sir, for your excellent explanation. Now, the webinar is open to participants. Participants, if you have any doubts, please unmute yourself and you can ask the doubt.
Sir, good evening, sir. My name is D. S. Naidu, research scholar. Are you audible, sir?
Yeah, you're audible.
Yes, I'm hearing.
Yes, sir.
You're audible, yeah.
I am doing my research in the area of nanofluids, sir, heat transfer applications. Sir, regarding, is there any application regarding nanofluids? Actually, in real-time application, is there any available, sir, recently? Real-time applications. Actually, so much of literature is available, all the properties and heat transfer applications and all. Actually, is there any real-time applications? As
Thank you very much, sir, for
yes, sir.
your question.
Yes, sir.
Actually, it's a new development and new technology. As I told you, the future, in the near future, we will have so many unbelievable applications of nanotechnology. So the nanofluid, the before 1 week ago, I was really joined one interesting international webinar. From the webinar, I heard that they are on the way to apply the nanofluids, especially for the mechanical engineers. They are trying to implement or to make it through for nanofluids. So I think this is applicable nowadays.
Okay, okay, sir. I heard that this is mostly nanofluid used in water blocks for heat transfer applications like in laptops and all, sir. Actually, that is it enhances the heat transfer rate and life of the device increase and the laptop maybe become portable, sir. That is application only I heard, but the scale level, like practical implementation wise, I didn't heard, sir. That is the what I said. Okay, that is the thing. Okay, sir. Thank you.
Okay.
Yes, sir.
Thank you, sir. Any other participant?
Yes, sir. Thank you. Thank you very much, sir, for your nice presentation, sir. Thank you.
You're welcome.
Yes, sir. Thank you.
Any other participants? If you have any doubts, please unmute yourself and you can ask the question.
Should I ask
Defeat
a
the
question?
link. Yeah, you can ask.
Myself, Dr. Pankaj Kumar Singh from IIT BHU. In concern to the topic, I have already done some work on the nanotechnology. My question is that regarding the fuel cell you have said, can you tell something about the SOFC?
The fuel cell?
Yeah, that the fuel
Okay.
SOFC. What is that SOFC? Can you tell something about that?
Yeah, the fuel cell, the issue is that nanotechnology is it has a very wide application. For fuel cells are very one of the application of this technology. So the fuel cell is the issue is that how can we produce an efficient device for fuel cells. So this is also I mean one application of nanotechnology, and people are working so many interesting things on this issue also. Can you make it your question very clear, sir?
It is solid oxide fuel cell. You heard about this?
Yeah,
Pankaj,
I actually read different literatures from different literatures about this one. I even make a review on this issue for my PhD dissertation. So this is a very important topic. Hello, sir.
yeah,
Important.
yeah,
What is that? Can you say something about that SOFC?
yeah, Pankaj sir. Actually, there will be some echo will be there, sir. Some time gap will be there. So you can just talk a little bit slowly,
Yeah,
sir, so that you will hear, sir.
Okay, okay, no problem.
Because in Ethiopia, some small technical internet issue is there now.
the problem is that I am using the cell phone internet. The electricity really switched off. So maybe the internet problem is there.
Okay,
My
no problem,
internet
sir.
is not very strong.
Sir, Asaman sir, if possible, can you just type your mail ID in the chat box so that participants, if they have any doubts, they will mail you directly also.
Yeah, sure. I will put it here.
I will type. Any other participants, sir? If you have any doubts, please unmute yourself and you can ask the question. If there is no other question, Dr. Santosh Mitra, sir, and Dr. Devesh, sir, can we conclude, sir?
Conclude, sir.
Yeah, Manoj Mirjakar, you can ask, sir.
Very good evening, sir.
One question,
Yes,
sir.
sir. Yes, Vinod sir will answer all the questions.
In case of a metallurgical, that is powder coating, one metallurgical aspect, that is the powder coating of some mechanical components. In that one, also the nanotechnology is used, means can be used.
Yes, sir. It's possible to use.
Okay, sir. Thank you.
Any other participants? If you have any questions, you can ask or we can wind up the session.
Yeah, I put my email there, and then if you have any question, you can send me a request, and we'll talk and we'll share different literatures about nanotechnology.
Thank you, sir. Actually, it was an excellent presentation, and thank you, sir, for spending your valuable time with all the participants. I think today more than 98 to 1 or 2 participants they attended our event from various parts of the world. So I thank personally I want to thank you, sir, for your excellent presentation. Now I'm hand over the session to our host college Villa Institute, sir. Dr. Santosh, sir, or
Sir,
Dr.
Hello.
Devesh. Yeah, we can conclude our session, sir. Or Saina, ma'am.
Okay. Yeah, I'm here. A very good evening to all present over here. I'm Dr. Sheena Shekhar, Professor and HOD Mechanical Department, Bhilai Institute of Technology, Durg, Chhattisgarh, India. Durg is a city in Indian state of Chhattisgarh, east of Shivnath River, and it is a part of Durg Bhilai urban agglomeration. It gives me immense pleasure to thank all the dignitaries present here. On the outset, we were so lucky to have eminent resource persons like Dr. Raja Sridharan from Rabat International University, Morocco, who spoke on managing manufacturing industries in the vortex of VUCO world. Dr. Raghuram from Amruta University, Coimbatore on lean manufacturing concepts and case studies. Dr. Manimuthu from Cyber Security Research Center, Nanyang Technological University, Singapore on applications of IIoT and autonomous vehicle system design, and Dr. Balaji from Amrita University again, Coimbatore, on advanced fluid mechanics practical approach. And today we had our eminent chief guest, Dr. Asaman, who honored this function with his inspirational talk. Your talk on nanotechnology was one of the most interesting topics in the forum. It was an honor for us to have you all as resource speakers. We believe that the knowledge you have shared will help immensely in the development of the sector and eventually translate into better programs that will help research scholars pursuing in this line. Your presence and experience gave us more meaning to this international FDP on modern research trends in mechanical engineering. We know your time is precious and we are grateful that you all shared some of it with us. From the very beginning, you all knew exactly what we had to do to make this FDP successful. Thanks to all of you. We are much thankful to all the participants for your gracious presence and making it a huge success. We hope that all of you have found the FDP informative and worthwhile, and our primary goal was to increase your understanding of research trends in mechanical engineering. Now, I would like to take this opportunity to thank Volo University for collaborating with us to organize this FDP. My special thanks to Dr. Prabhakar, who stood as a backbone to conduct and organize this event successfully. It was a great experience with you, sir, and I hope to work with you in the future as well. The way you deal with is really a matter of great appreciation. Also, your team works with a great effort and it's your best quality. We would also like to express our sincere gratitude to you and your team. Thank you for all your cooperation and we look forward to more years of working in collaboration. Last but not the least, I would like to express my respect and gratitude to BIT management and Sri IP Mishra ji, BIT Trust member, Dr. Arun Arora, Director, Dr. Mohan Gupta, Principal, Dr. Manisha Sharma, Vice Principal, for permitting us to organize this event and providing us all facilities for research, work, and special gratitude to my teammates and backbone for organizing this event, Dr. Shabana Nas Siddiqui, Dr. Devesh Srivastav and Dr. Santosh Mishra, and especially all my dear mechanical department faculty members who have been supporting us unconditionally throughout. Thank you so very much, and hope to meet again in the forthcoming events. Thank you, sir. Over to you,
Thank you, ma'am.
Prabhakar, sir.
Thank
Yes.
you, ma'am. As a token of love from our side, actually, we are planning to issue one certificates for you, ma'am. Are you there, ma'am?
Okay.
1 minute,
Yes,
ma'am.
sir.
I will share this. 1 minute. Thank you, Dr. Asamin, sir. Just 1 minute, ma'am.
Yes, sir.
As a token of love from our Volo University, we want to appreciate you all, ma'am. So this certificate
Thank
is
you so
for you,
much.
ma'am.
It's so beautiful. It's very, really beautiful. Thank you. Thank you
Uh,
so much.
and to your teammates also, ma'am. Thanks to Dr. Arun Aura, Director, sir. Thanks to Mogan Gupta, sir. Principal, sir. Thanks to Dr. Santosh K. Mishra, Associate Professor, Mechanical Engineering Department, Billai Institute of Technology, Durg, India. Dr. Sabna, ma'am, Associate Professor, Mechanical Engineering Department. Dr. Divesh, sir. Divesh Srivatsa, Associate Professor for Mechanical Department, and Dr. Manisha Sharma, Vice Principal, Billai Institute of Technology. I want to thank you all, ma'am, for your support, because without your all support, this FDP wouldn't be impossible. So thank you, ma'am, for your support, and I thank all the participants who attended all the sessions. I want to thank all the participants, because without the participants, this event wouldn't be a thing. So I would thank again all the participants for making this event a great success. I think more than average, if you just see, more than 100 to 150 participants, they attended our event, ma'am. So I want to thank all the participants, and I want to thank all the management members of Billa Institute of Technology, and I want to thank all the management members of Ola University, Kombolcha Institute of Technology, Ethiopia, for this wonderful FD program. Thank you all.
Thank you. Thank you so much.
Thank you, ma'am.
Thank you so much, sir, for your cooperation. Thank you so much,
Thank you,
Reena
sir.
Shekhar ma'am, for
Welcome.
guiding and constant guiding us.
It was you people who had done it, and I was just on
Better
the
we can,
backbone.
ma'am, better we can on our camera for group photo.
Yes,
Yeah,
ma'am.
everyone, please.
Yeah.
At least
Prabhakar sir, you
those
also.
1 minute, sir. Yeah, 1 minute, sir. I will stop sharing. 1 minute. 1 minute. Yeah.
hello, sir.
Thank you all.
Thank you. Thank you so much.
Thank you, sir.
Thank you, ma'am.
Thank you.
Thank you.
Thank you. Thank you, sir.
Okay, ma'am. With your permission, we can conclude the session, ma'am. So that participants, I think
Yes, sir.
most of the participants, they got the certificate, which is
Yeah.
automatic generated certificate. So within 1 hour, the certificate will be deactivated. The certificate link.
Thank you, sir. Thank you so much for all the work that has been done so automatically. Thank you.
Thank you so much.
Thank you, ma'am.
Thank you, sir.
So we can leave now.
Yeah, ma'am. They can leave.
Okay. Thank you.
Thank you, participants. And
Thank you. Thank you
tomorrow,
for
our Dr. Shaina Segar ma'am is going to like present another one webinar for Vola University at Indian timing 11:30. So I request all the participants. Today night I will send mail to all the participants. So I request all the participants to attend tomorrow webinar also. Thank you, Ananda.
I welcome all of you all
Thank you.
on my behalf also. I hope you will be fruitful to you all.
Thank you, ma'am.
Thank you.
Thank you, Dr. Devesh sir, and thank you all. Santosh sir, thank you all.
Hello.